Hello, Math 141. Let's look at one of the problems that many of you requested for me to do a video on that. Let me share screen and hopefully you can see uh, my screen. Section 3.7, number 14. If 1500 square centimeters of material is available to make a box with square base and open top, find the largest possible volume of the box. Do not use calculus to solve this. Of course, everybody know that using calculus would be much easier to do a problem like this, but let's use algebra. Okay, uh, now that you know what the problem is, let me get my, let me stop share and get my iPad involved. And give me 1 second and continue. And okay, now I can write for you. So what is it that we know? We know that we are a box with, after a box with open top. So here is a box. And the problem is telling us that the base is, the shape of the base is square. So if this is X, then this is X. And the bases, the sides go up. We don't know for how long, and there is no top. The first thing that I've seen students, including myself years ago, think is, oh, this must be a cubic box. I would get the largest volume. That would be true if the box had a top, then we would be after a perfect cube. But since it doesn't have a top, I cannot count on that. What is it that I can count on? I know that I have total of 1500. So if I if I was to make a cube, if I had to make a cube, I would say, okay, cube root of 1500 roughly equals to 11.447 centimeter. Okay, so I know that the sizes of the eggs and genome, they're going to be roughly on the neighborhood of about 12 centimeter. All right, what else do I know? I know that the volume, of this box has to be x squared. Let's call this here y times y. Okay, and if I wanted to have very large base and practically very small sides, the most I could do, I could say that, okay, x squared, which is uh, the size of this square base, has to be smaller than 1500. So x square root of 1500 is, put that on the calculator. So x has to be smaller than 38.73. So and the reason I need this information, I want to know roughly where am I going to be landing with this problem. Okay. And what else I understand? I understand that x must be positive and y must be positive, because the volume has to be positive. So if I'm to graph this by any means, all I have to look for some values that both values of x and y are positive. Okay, so let's continue on the next page. Having said all that, the last piece of information that I'm going to be using, I know that I have 4 walls on that box. So if here's my box, you see, each wall is, so we said these are x, and each height for the wall is y. So, and I have 4 sides. So 4 times xy plus the material that I use for the base for x squared has to equal to 1500. Why? Because the problem is telling us. And from here, what I can do, I can solve for y. Solve for y. Subtracting x squared from both sides give me 4xy equals 1500 minus x squared. Dividing both sides by 4x gives me y equals 1500 minus x squared all over 4x. And so now that I know y equals to that, I can go ahead and substitute that in my volume. I know that the volume equals to the area of the base, which is x squared, times the height, which is y. So I can substitute this amount in here. This way now I only have one variable. Let me go to the next page. So I have volume equals to x squared times y. So volume equals x squared times 1500 minus x squared divided by 4x. And I can simplify that a little bit. 1500 times x squared divided by 4x gives me 375x. And x squared times minus x squared is divided by 4x. That gives me minus 1/4 of x cubed. Okay, so what I'm gonna now go ahead and rewrite this in blue. That volume equals 375x minus 1/4 x cubed. And now I'm gonna go ahead and graph this on Desmos. Okay, graphing this on Desmos. Let me, I'm going to disengage my iPad so that I can show you my screen again. Okay, so let me share screen and go to Desmos. All right. So what you see here is 375x minus 1/4 of x cubed, or minus 0.25x cubed. And this is the graph of this function. And remember that we said that x has to be positive and y has to be positive. And I already located for you the local maximum right here in this graph. Hopefully you can see it. So the value of x is 22.361 at the, at the vertex. So once again, I'm going to go ahead and stop share and engage my my iPad. Okay. So now that we know that we have a local max at x equals 2.361. Okay. And we said that the volume equals 375x, in this case 22.361, minus 1/4 or 0.25, 22.361 cubic. I already put that in the calculator, and that gives me 5590.1699. That's good enough. And what is the unit? It's cubic centimeter. So I'm going to put centimeter cubed for that. So why probably at this point some of you think that if using calculus pretty soon makes this problem very easy, why are we pushing to see problems like this? And the design of, I believe whoever designed this question wants you to understand the fact that when you look at the Cartesian coordinate, we're using Cartesian coordinate for a linear function, for a quadratic function, for a cubic function. Although you think of all this as x and y, it can represent different stuff. Here's what I mean. Think of the first basic thing that you learned, that y equals x, and you had something like this. Okay, here was your graph. This is your x, and this is your y. Then you had something like, you learned something, y equals x squared. Okay, when you graph this, y equals x squared, so remember that when x is 0, y is 0, when x is 1, y is 1, and when x is 2, 1, 2, 3, 4. So you have a shape like this, and it goes like on the other side. So although you see the y as the height of your graph, geometrically, notice that if this is x and this is x, geometrically, the height of that graph represents the area of this tile, of this square with the side x. Similarly, when you do y equals x cubed, okay, so you have something like this, x and y. When x is 0, y is 0, 1 goes to 1, and 2 goes all the way 8 somewhere here. So you get a graph, something like this. And so although you see it as x and a y, so y in here for 2, let's say this point you see, let's say 2 comma 8, right? And 8 is the height of the y value when x equals to 2. But geometrically, what happens is, this in fact is when you have a box with a cube right here, and each side is 2, a 2 here, and a 2 here, and a 2 here. So the volume of this box, which is 2 times 2 times 2, which is 8, okay, could be represented using Cartesian coordinates. And so these problems are designed for you to think about how graphs can help you representing geometric and physical properties, physical problems, real world application using what we are learning in pre-calculus and before and after. Well, I hope this was helpful. Thanks.